Welcome back. Today we're going to be talking about identifying exponential functions. First, we're going to take a look at comparing exponential functions to linear functions. So let's go ahead and take a look at that now. So here, when comparing linear functions and exponential functions in a table, we can see we've got y equals 2x, which is our linear function, and y 2 to the x as our exponential function. We're going to substitute in like we always do. So 2 times 0 would give us 0 on the linear, 2 times 1 is 2, 2 times 2 is 4, 3 times 2 is 6. So it's just multiplication. For our exponential function, when we substitute in, we're going to be taking things to the power. So to the 0 power, anything is 1. 2 to the first power is going to be 2. 2 to the second power is going to be 4. And 2 to the third power is 8. So everything's going up by an exponential amount as opposed to just multiplication. Let's see what this does now on a graph. So now looking at a graph, we can see that our linear function, y equals 2x, is going to create a line because every time we're going up 2 over 1. Our slope is fixed. In an exponential function, however, we see that our graph is going to make a curve because the rate of change in this case is not constant. With the linear function, the rate of change is 2. Every time it's going up by 2 and over 1. And an exponential function, because that rate of change is changing, it's going to cause our graph to become a curve. Now let's take a look at a few reminders about linear functions. So a few more reminders about linear functions. A linear function makes a line when graphed. We show linear relationships with the equation y equals mx plus b, or f of x is equal to mx plus b. Now let's take a look at an exponential function. With an exponential function makes a curve when graphed, and we showed the exponential function with the equation y equals a parentheses b to the x power plus k, or f of x equals a parentheses to the x power plus k. Now let's take a look at what all of those things in that equation represent. So in an exponential function where we've got y equals a parentheses b to the x, and then our constant. So we know our dependent variable is going to be our y, our independent variable is going to be an x. Those things are similar. They come across from our linear equation. Our y-intercept in this case is going to be the letter a. We are going to have a base, which is new. So the base to the independent variable, that's going to be b. And then we have a constant, which is our k. Now we need to talk about one more important term before we begin using exponential functions. That important term is known as an asymptote. An asymptote is a value that y values approach but never reach. So an asymptote is a y value as they're reaching it, the curve is turning towards it, but it is never going to reach that amount. So now that we've talked about comparing linear and exponential functions, let's do some practice. So here in example A, it says write the rule and identify the domain and range of this function. So our rule is y equals 2x. So we don't have to write the rule. They already did it for us. We now need to identify the domain and range of this function. So we can see that in the domain, the curve starts from -10, is off screen. It's got an arrow there. It's going all the way into the negatives as far as it can go that direction. And we can see that although it curves and it's still going up and out, it's going to continue to go up and out forever. So it's going to continue while we can't see it on the graph, it is going to cover the entire domain. So our domain in this case is going to be -infinity because it's going all the way the opposite direction, and +infinity because it's going all the way up and out. So that's our domain. Our range, on the other hand, while we see that it is going to go up forever because it's going to go up to the y values, it's going up forever. It is, however, not going to go down forever. It's going to go down until it hits that asymptote line where it's not able to exactly reach that. And in this case, that number is 0 because we don't have any constant there at the end of our rule, right? We see no number here. So that means that our range in this case is going to be going from 0, which is our asymptote, to +infinity because our line is going up and out forever. So those are our domain and range. Now let's take a look at example B. So here in example B, it says complete the table to match the graph and the function. So we've got a table there that we've got to complete, and they've already given us the rule. Now we can do this one of two ways. If they've given us the graph, we can pick points on the graph. So I see that there's a point here and a point here and a point here. So I could select points that are integers on the graph and substitute them in my table. But if my table's not here, I'm going to have to pick numbers and plug them in. So I'm going to pick 0 in this case and 1 and 2. But you can pick whatever numbers you want. Again, this graph goes up to 10 and -10, so you probably don't want to pick x values that are more than that. or they won't be on the graph. If you don't have the graph, you're going to have to substitute in your x value. So in this case, we have y equals, the first one would be 0. So we have 2 to the 0 power. Remember to use parentheses when you sub in, plus 3. Now, if we simplify that, 2 to the 0 power is 1. We end up with y equals 1 plus 3, and 1 plus 3 is 4. So we would end up with y equals 4. So we could check, does that work out in our graph? So we've got 0, 4, so we'd have 1, 2, 3, 4, and yeah, that was one of the points on my graph. So as long as I'm substituting in, following my order of operations, because again, I would be doing things to the exponent first and then doing the addition, I can do that as well. If I'm looking at my graph though, to read the points on the other end, I've got 1 is 5 and 2 is 7. Notice that it's an exponential graph. It's not going up by just common same number every time. All right, now let's take a look at the last example. Here in example C, we've got to complete the table to match the graph, but again, there is no table. So in this case, we're going to just find the domain and range. And it says y is equal to 3 to the negative x. So and we can see that that's caused our graph to flip the opposite direction of the graphs that we've seen so far. We've got to identify the domain and range. So again, we're looking at our x values. And again, it's going to go up and out as far as it can to the left, and it's going to go on forever and ever. Same thing with the line down off to the right. It's going to the right forever and ever. So in both cases, our domain again is going to be negative infinity and positive infinity, because in both directions it's going as far as it can forever and ever. That's not the best looking infinity sign. Let's see if we can clear that up. All right, now we're going to look for our range, and our range, again, we can see that it's going up as high as it can. So it's going to go up and out as far as it can. So that appears that it's going into the y value infinitely as high as it can. But again, it can't go down below the asymptote. And again, this case, we've got no number here to indicate that we have an asymptote. So our asymptote is 0. And we can see that as our curve is getting closer to that line, but not exactly reaching that line. Because even though it appears that way, remember the decimal can always get smaller. You can get 0.4 and half of that is 0.2 and then 0.22 and then 0.222 and then 0.2222. So on and on and on. So it can never reach that asymptote, but it can continue to get close to it. So our range in this case is going to be 0, because again, 0 is going to be smaller, and positive infinity, because again, we know it's going on and on up as high as it can go. That brings us to the end of this problem. It also brings us to the end of this set of notes and this video. If you like this video, go out there and say thumbs up. If you love this video, go out there and say sub, and we will catch you in the next one.